Hello, this is a short video presentation on dividing imaginary numbers. You will find that this is very similar to what we were doing when we divided expressions that had irrational numbers in the denominator. There are two cases that we look at. The first case is when the denominator is a monomial. So, for instance, we could look at a problem like 4 plus 3i divided by I. Let's make it 2i. Now, just like we could not have a square root in the denominator, we cannot have I in the denominator. No imaginary number in the denominator. So, the question is, what is I times I? If you remember from Monday's class, I times I is -1. So we multiply numerator and denominator by I. That gives us 4i, distributing the I, plus 3i squared over 2i squared. Or 3i squared is, I squared is -1, so we get -3 over -2. I squared again is -1, -1 times 2 is -2. Now we're not allowed to have negatives in the denominator, so we multiply by -1 over -1, which gives us 4i times -1, -4i plus 3 over +2. And then we rewrite this in a plus bi form. So we take this part, 3 over 2, plus, in this case minus, 4 over 2, or 2i, minus 2i. Or we can write that as 3 minus 4i over 2. Either way is acceptable to write it. Whether you write it like this or like this, it's really the same thing. So this is our answer. What's important is that we always write it in a plus bi form. We have a, the real part, plus the imaginary part, or in this case, subtraction. All right, that's the first type of problem, and it's pretty simple. We're just getting rid of I in the denominator. The second type, first of all, though, before I show you an example, I want to look at a multiplication problem, 2 plus 3i. And what do you think the conjugate is? What do you think the conjugate of 2 plus 3i? Thinking back to rationalizing the denominator, the conjugate is 2 minus 3i. Only thing that changes is the plus became a minus. The sign of the 2 stays the same. And when we FOIL this, 2 times 2, 4. 2 times minus 3i minus 6i plus 6i. and minus 9i squared. The minus 6i and the plus 6i are opposites. They cancel, and we're left with 4 minus 9 times negative 1. Negative times negative is positive. 4 plus 9, or 13. When we multiply by the conjugate, we no longer have an imaginary number. Totally gone. So now let's look at a problem. We have 3 plus 2i divided by negative 2 plus 4i. So, we're going to multiply by the conjugate, negative 2 minus 4i. Notice that the negative 2 stays the same. The only thing that changed right here is the minus came from the plus. And please write it like this. Write it, show the fraction bar, show the multiplication, show everything. Some of you I've asked to fix this. Now, when we multiply by the conjugate, we will not have an imaginary number. Negative 2 times negative 2 is 4. Negative 2 times negative 4 is plus 8i. 4 times negative 2 is minus 8i. And 4i times 4i minus 16i squared. Numerator, 8i's cancel. All right. Now we have 3 times negative 2 minus 6 minus 12i minus 4i and minus 8i squared. So now I'm going to combine my like terms. I have the negative 6 and the negative 8i squared. So I have negative 6 minus 8 times negative 1, and minus times a minus is plus, minus 16i over 4 minus 16 times negative 1. Again, that becomes plus. Do this in a different color. And I end up with negative 6 plus 8 is 2 minus 16i over 20. Now, since I can divide everything by 2, we end up with 1 minus 8i over 10, or 1/10 minus 4/5 I, reducing 8 over 10 to 4 over 5. Either form is acceptable. Does not matter to me. All right, I hope this is understood. Remember, no imaginary numbers in the denominator. So you're either going to multiply numerator and denominator by I, or you're going to multiply by the conjugate. All right, thank you. I hope that makes some sense. I hope it's clear, and have a great day. Hasta mañana.